Hey guys, back for part 2 of trigonometric equations. We are going to look at some harder types of problems. All of these include factoring or some type of Pythagorean substitution. We even throw in some extraneous solutions. And the third type, you're going to start getting a period switch on the graph, which is going to start creating more than two solutions like we're used to. So we're going to jump right in to factoring here. I've pulled two different equations. Now you're going to know that this is different than the old factoring methods that we did yesterday because you'll notice that you have two different trig functions. So that's a clue. I'm going to need to do a substitution here. The Pythagorean identity we're going to be dealing with here with the first example is the sine squared plus cosine squared equal to 1. And I'm going to need to replace cosine squared with 1 minus sine squared. So 2 times 1 minus sine squared theta plus sine theta equals 1. Now I'm going to distribute that out. 2 minus 2 sine squared plus sine theta equals 1. Our goal here is to set this up to factor, so of course it would make more sense to have a positive leading coefficient, so I'm going to move everything over to the right side of the equation. 2 sine squared minus sine theta, subtract 2 from 1, and that'll leave you with negative 1. Now we're going to factor that. If you like switching that to the x variable instead of sines, if that helps you factor, feel free to do that here. I'm going to go ahead in the interest of the space I have and skip that step, but if you want to do that on your own paper, feel free. So you can pause the video and do that real quick. So I've got 2 sine theta and sine theta. And then I need to figure out what multiplies to give me negative 2 and adds to give me negative 1. So that would, of course, be negative 2 and 1. So this needs to be minus 1, and this is plus 1. So now you're going to set both those factors equal to 0. So that's going to give me sine theta equals negative 1/2, and sine theta equals 1. Now you're right back where we were yesterday. You need to use inverse trig. And also think about the quadrants where sine is negative. So that happens, let me add my ASTC chart here as my reference for the positives and negatives. So sine is negative in the third and the fourth. That's where my two answers need to come from. So my reference angle is pi over 6. So the third quadrant there is 7 pi over 6, and the fourth quadrant is 11 pi over 6. So there's my two solutions off of that factor. And then over here at sine theta being positive 1, that's going to be on the quadrantals. So if I kind of draw that over here, trying to think where the y value would be 1. So that would happen here at pi over 2. So I get one solution for that factor. So that gives me overall 3 solutions for the first example. Okay, moving right along. Let's switch up my color here. Now I'm going to throw in tangent squared. So that is using a different trig identity. That's using your, if you divide through by cosine, I'm running out of room a little bit here. I'm going to erase that for a moment and think about if I divide this original by cosine squared, then that gives me tangent squared theta plus 1 equals secant squared theta. So I'm going to do that substitution, solving that for tangent squared would be secant squared theta minus 1. I guess I don't really need that parenthesis. Get rid of that before I confuse too many of you. So secant squared theta minus 1 minus 2 secant theta equals 2. Once again, we need to set up to factor, so I'm going to have the quadratic term first, secant squared, minus 2 secant theta. If I subtract 2, that'll be minus 3 equals 0. Now I'm ready to factor. Just regular old trinomial factoring, just instead of x and x, we're going to have secant theta, multiplies to give you negative 3, adds to give you negative 2 would be negative 3 and positive 1. So now I'm going to have, where does secant theta equal 3, and where does secant theta equal negative 1. Now anytime you're dealing with reciprocals, you do want to switch to the reciprocal function and switch the right hand side. So where does cosine theta equal 1/3? And, cosine theta. Where does cosine theta equal the reciprocal of negative 1 is still negative 1. Now, cosine theta equals 1/3. 1/3 is not on the unit circle, but 1/3 is less than 1, so this is still possible. What you're going to do is, if you have your calculator handy, and if you don't, you could always Google, you're actually going to use the inverse trig function, so secant cosine, and type in 1/3. And make sure that you are in radian mode on your calculator when you're doing this. So inverse cosine, secant cosine, 1/3 would give you 1.23, and that's for the first quadrant answer. And then also cosine is positive in the fourth quadrant. So the easiest way to get a fourth quadrant answer is to simply put a negative in front of that. So negative 1.23. I'm not going to give you a lot of questions where you have to use the calculator because it does get confusing, but sometimes when you solve by factoring, it's really hard to make the factoring question work where everything's on the unit circle. So just know that occasionally you will have to put them in the calculator. Okay, and then where does cosine equal negative 1? So that's a quadrantal point. So over here you got negative 1, 0, and that happens at pi. So there's your other solution. Alright, so that's factoring with a Pythagorean substitution. Now let's go down to the second type of question where you need to square both sides. Now the way I know I need to square, even though you still have two different trig functions, there's no way that I can sub in a Pythagorean identity if I don't have a squared trig function. So before I can sub in a Pythagorean, I need to square both sides of your equation. So I'm going to do that with the first one. Now be careful, when you square a binomial, don't forget about your middle term. So this is going to be cosine squared theta. Cosine times negative sine times 2 is minus 2 cosine theta sine theta. And then plus sine squared theta equals, the other side, obviously 1 squared is 1. Then we're going to clean this up a little bit. Right here, cosine squared and sine squared is equal to 1. Minus 2 cosine theta sine theta equals 1. Then you're going to solve by subtracting 1 to the other side. That would give me 0. Dividing by 0 by negative 2 takes you to cosine theta sine theta equals 0. Now technically you have two different factors set equal to 0, so I can set those separately equal to 0 using the zero product property. So where does cosine equal 0 and where does sine equal 0? So this happens obviously on the quadrantal points. Cosine is equal to 0. The x value is 0 at pi over 2 and 3 pi over 2. And sine is equal to 0 at 0 and pi. Now, before I finish and say, well, those are the 4 answers, with this type of problem, you have to check for extraneous solutions. You have to check and plug back in your answers. So I'm going to take pi over 2, and I'm going to do, and I'm running out of room a little bit, but I'm going to do cosine pi over 2 minus sine pi over 2, and see if that gives me 1. Obviously, cosine pi over 2 is 0, minus the sine of pi over 2 is positive 1. So does 0 minus 1 equal 1? No. So this one is extraneous. You're going to do that same thing with 3 pi over 2. So I'm going to just squeeze in here cosine 3 pi over 2, sine 3 pi over 2. Cosine 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. So 0 minus negative 1, 0 plus 1 does give you 1. So that works. So 3 pi over 2 is a solution. So if that makes sense, you're just going to plug in to the original problem and check to see if your answers work. So I'm going to do cosine 0 minus sine 0 and see if that gives me 1. Cosine of 0 is 1 minus sine 0 is 0. So that does check out. Then you're going to do pi. Cosine of pi minus sine of pi. Cosine of pi is negative 1. Negative 1 minus 0 does not give you 1, so that's also extraneous. So your 2 solutions here, even though you did everything perfectly right, you only get 3 pi over 2 and 0 as your answers. You do not have to check every single one of these, only the ones you square both sides. So they take a little bit of time. Alright, next to go, we've got tangent theta plus 1 equals secant theta. I'm going to square both sides again to start with. Draw little lines so I can see where this problem is and the other one ends. So that's tangent squared theta plus 2 tangent theta plus 1, squaring that binomial, equals secant squared theta. We're going to go back up here to remember our trig identity, Pythagorean trig identity using tangent and secant, see what I can do with that. So tangent squared right here plus 1 is equal to secant squared plus 2 tangent theta equals secant squared theta. That's going to cancel secant squareds, so you got 2 tangent theta equals 0. Divide by 2, that's tangent theta equals 0, and so the angles whose tangents is 0, that happens at 0, and pi. And then we're going to need to check both of those to see if you get extraneous. So tangent of 0 plus 1, is that equal to secant of 0? Tangent of 0 is 0. Secant of 0 would be 1 over the cosine. Cosine of 0 is 1, so 1 over 1 is 1. So 0 works out. Let's try pi. Tangent of pi plus 1, does that equal secant of pi? Well, tangent of pi is 0 plus 1, that works. Secant of pi, however, is 1 over negative 1, which is negative 1. 0 plus 1 does not equal negative 1, so pi is out. So the only solution there is 0. So just remember, I got to double check only the ones where I square both sides. When you square both sides on any type of algebraic problem, you are creating multiple solutions that were not there in the first place. So just keep that in mind. Alright, so the last type of problem we have here is called multiple angle problems, and I'm going to fill in my trig chart again so you have that for reference. 1/2 square root 2 over 2, square root 3 over 2, square root 3 over 2, square root 2 over 2, 1/2, square root 3 over 3, 1, square root 3. All Alright, so multiple angles. I put two little diagrams down here at the bottom just to kind of get you to understand how this works graphically. The first thing you're going to do with your multiple angle problems is solve for the trig function. So cosine 3 theta equals a half. So you think back to how we did this with the other note sheet. I can think about where the graph of cosine intersects with a half, and then think about how many solutions there would be. So if I'll just look at the first graph represents just y equals cosine theta, and the second graph represents cosine 3 theta. Remember, 3 theta changes the period of the graph, so it looks much closer together. And then you can see that, let me color code it for you. I have graphed on here the line y equals a half. Get that a little thicker for you. So we can see how many intersection points there might be. So the intersection points with cosine theta from 0 to 2 pi, you just have two intersection points, one in the first quadrant, one in the fourth quadrant. And that makes sense because cosine is positive in the first and the fourth. But intersection points with cosine 3 theta, you have 1, 2, 3, 4, 5, 6. So where we had two solutions with 1 theta, you have 6 solutions with 3 theta. So our multiple angle problems will create many more solutions because it makes total sense if you think about intersection points with the graph. If you crunch the graph up, you're going to have 3 times the intersection points that you had before. If it would have been 2 theta, it would be 2 times. If it's 4 theta, it's 4 times as many solutions. So just keep that in mind. That's what makes these a little bit trickier. Alright, so moving forward to continue solving this problem, now I need to solve for my 3 theta. It's called the argument. So 3 theta equals inverse cosine of a half. And then you go ahead and treat that like it was regular theta. Just think about what 2 quadrants is cosine positive in. That would be the first and the fourth, and then get your reference value. So that would be pi over 3. So 3 theta equals pi over 3. Fourth quadrant, 3 theta equals 5 pi over 3. Now, you need to add 2 pi k, like we were doing the general solution. Because what's going to happen now is you're going to divide by 3 to solve for theta. Dividing by 3 is the same thing as multiplying by a third, and then divide by 3 here. And that's going to give you your first solution. So theta equals pi over 3 times 1/3 is pi over 9. Then you get your next solutions by taking pi over 9 and adding 2 pi over 3. Now what makes this complicated is, of course, finding a common denominator. So up here, where I had some white space, I'm going to make 2 pi over 3 have a common denominator of 9. So times 3 times 3, so that's going to be 6 pi over 9. I need to add 6 pi over 9 to get my next answer. So 6 plus 1 would give me 7 pi over 9. And then I need to add again, because remember, I need to get 6 answers. So there's 1, 2. The next answer, 7 plus 6 would be 13 pi over 9. So I get 3 answers from the first quadrant. You're going to do the same thing with the fourth quadrant. Divide by 3, same thing as multiplying by 1/3. Divide by 3. So my first answer, 5 pi over 3 times 1/3 is 5 pi over 9. To get my next answer, I need to add 2 pi over 3 to that. So again, common denominator means I need to add 6 pi over 9. So 5 and 6 is 11 pi over 9. And then my last answer, that's 5, I needed 6, is 17 pi over 9. There's all your solutions. So most people think these are the most complicated problems simply because you get way more answers than you normally would. You do not have to check for extraneous solutions though, because we didn't square anything. So that's a plus. Alright, last example, and I'll let you go do your work. So same thing, I've got a multiple angle here, so first thing you're going to do is solve for the trig function. Cosine 2 theta equals negative a half. I'm going to draw a little line so I can separate my work here. So now you're going to use inverse trig, solve for 2 theta. So 2 theta equals inverse cosine of negative a half. Cosine is negative. A is to C. In the second and the third. So that's the quadrants my solution should come from. So 2 theta equals, the second quadrant, cosine a half is pi over 3. So my second quadrant angle is 2 pi over 3 plus 2 pi k. My third quadrant angle is 4 pi over 3 plus 2 pi k. Now we solve for theta by dividing by 2, which is the same thing as multiplying by a half, divide by 2. So, first answer would be 2 pi over 3 times a half, which is 2 pi over 6, which reduces to pi over 3. Second answer you're going to get by adding pi to that. Pi with a common denominator of 3 would be 3 pi over 3. So if I add 3 pi over 3 to that, then I get 4 pi over 3. So pi over 3, 4 pi over 3. That's 2 answers. I need 4 because it was 2 theta. So keep going, divide by 2, multiply by a half, divide by 2. So my next answer is going to be 4 pi over 3 times a half, which would be 4 pi over 6, which reduces to 2 pi over 3. And then add pi to that, so add 3 pi over 3, so you get 5 pi over 3 as your final answer. So I hope you hung in there. That's all my examples. See if you can work on the Google form. If you get stuck, as always, I'll meet you on Google Meet. Good luck.